So in chapter 3, we are already done discussing the different study types. We have the observational study types and then the interventional study types. Then we've already talked about ethics for the point of the researcher and as well as for the respondents, and then the studies that actually need ethical approval. Now at this point, we will now be discussing about variables and hypotheses. Okay, so these are measurable characteristics that assume different values among the subjects. This is simply variable. Variable or variables. And second, something that cannot vary or take on different values. This is constant. So basically, variable are just characteristics of a population that may assume different values depending on the respondent or depending on the sample. Okay, we have here the independent variable. The independent variable is basically the factor that is manipulated or controlled. Independent variable is the factor that is manipulated or controlled by the researcher, and the independent variable is also the variable that influences the outcome. We also have here the dependent variable, which is a measure of the effect, if there's any, of the independent variable. Now the dependent variable, contrary to the independent variable, is influenced by the independent variable. So again, the one that is being manipulated or controlled or being varied among treatment groups, that is the independent variable, and then such manipulation or such changes in the independent variable would actually cause changes as well on the dependent variable. Okay, so we have here a checkpoint. So I have here a list or a title of research papers or problems of research papers, and we need to identify the independent variable as well as the dependent variable of each of these. So first, the effects of a new medication on symptoms of depression. So independent variable, this is the variable that is manipulated or changed across group. So it is the new medication. And the dependent variable would be the symptoms of depression. Okay, effects of a new medication on symptoms of depression. You have new medication as the independent variable and the symptoms of depression as the dependent variable. So across treatment groups, you vary the medication either in the type of medication or in the dosage of medication, and you determine the degree of the symptoms of the depression. Next, investigating the effects of a new type of psychotherapy on symptoms of anxiety. Investigating the effects of a new type of psychotherapy on symptoms of anxiety. So the independent variable for this one is the type of psychotherapy or the new type of psychotherapy. New type of psychotherapy or just psychotherapy in general. Okay, and then the dependent variable, which will vary or will change after your intervention, which is your psychotherapy. That would be the symptoms of anxiety. Okay, so two examples: the effects of a new medication on symptoms of depression. The independent variable is a new medication. The dependent variable is symptoms of depression. And the second example, investigating the effects of a new type of psychotherapy, on symptoms of anxiety We have in the independent variable the new type of psychotherapy or just simply psychotherapy, and dependent variable as the symptoms of anxiety. Another example, what are the effects of dietary fiber consumption on the incidence of colon cancer among elderly males? What are the effects of dietary fiber consumption on the incidence of colon cancer among elderly males? So for the independent variable, the one that would be manipulated or would be changed across treatment groups would be the dietary fiber consumption. And the dependent variable would be the incidence of colon cancer among elderly males. So we have here, what are the effects of dietary fiber consumption on the incidence of colon cancer among elderly males? The independent variable, the one that would be manipulated, would again be the dietary fiber consumption, and the dependent variable, which would have changes after the intervention or the change in intervention, would be the incidence of colon cancer among elderly males. Okay, so at this point, we've already discussed about the independent and the dependent variable. Now would be the confounding variable. So confounding variable is defined as interference caused by another variable, interference. Okay? It is associated with both the problem and the possible cause of a problem, associated with both the independent as well as the dependent variable. So example here, in a survey to investigate whether there is a relationship between mothers who are cigarette smokers and the weight of their newborn. So the independent variable in this case, in a survey to investigate whether there is a relationship between mothers who are cigarette smokers, this is the independent variable, cigarette smoking. And then the dependent variable would be the one that would be affected, which is the weight of their newborn. Weight of newborn. So again, the independent variable in this case would be cigarette smoking among pregnant mothers, and the dependent variable is the weight of their newborn. Now, what would be the confounding variable in this situation? So again, going back to the definition of confounding variable, these are defined as interferences caused by another variable, and this variable is actually associated with both the problem and the possible cause of the problem, leading to an idea that there may be a relationship between these two variables, but it's only actually caused by a confounding variable. So a confounding variable in the example below would be, example, maternal diet, as well as lifestyle. So these two variables may be associated with both of the identified independent and dependent variable, and hence have led us to have this assumption that there may be a relationship between independent as well as the dependent variable, when actually it's only caused by the confounding variable. Okay, so another example to make it clearer would be example would be the rate of ice cream consumption. You have noticed that you have noticed that in the past few months, they actually have increased rate of consumption, ice cream consumption, rate of ice cream consumption. And then you have also identified, or you have also noticed that there are also increasing number of individuals with sunburns. So, having identified these two, one may think that an increased rate of ice cream consumption have caused increased sunburns, or increased sunburns have caused an increased rate of ice cream consumption. But what we don't know is the presence of a confounding variable, which, for example, would be hot temperature. Now, by discovering the presence of a confounding variable, the relationship between these two have now become clearer, because hot temperature would cause an increased rate of ice cream consumption to compensate for the heat. People actually go look for cold drinks or cold desserts, and hot temperature would also cause sunburns. So here is another example of a confounding variable, which is hot temperature, which has an interference on the relationship between rate of ice cream consumption as well as sunburns. Okay. Next, we have categorical variables, which belongs to nominal measurement. Nominal measurement means they are classified according to name. So when you classify variables according to name, they do not actually assume a value greater than the other that the variable may hold. So it does not give the idea that one is greater nor less than the other. For example, you have gender. Two classifications under gender we have, we have male or female, marital status, single, married, or divorced, hair color, blonde, brunette, redhead, or black. Now for hair color, this does not actually, as well as for the rest of these classifications, example, focusing on hair color, blonde individuals do not actually hold higher values compared to the brunette, compared to the redhead individuals, or the black hair colored individuals. So, meaning in categorical variables, the values they assume, they do not have any bearing whether they are greater than or less than the other. That is categorical variable. Next is discrete variable. So discrete variables, they take specific values only, meaning they can only have specific value which has semblance of absoluteness, or in simpler terms, the values that a discrete variable can assume would only be whole numbers. So example, in family size, if there are 5 members of you in your family, you cannot actually say that there's 5.5 or 5 3/4. That's actually absolute whole number that is used to designate the value of these variables. Like for family size, as what I said, 5 members, or for class size, you have 25 students. So please take a photo or a screenshot, as I think this is not in your lecture notes as well. Next, we have continuous variable. So continuous variable, from its name, can take on an ordered set of numerical values within a certain range or continuum. Again, your continuous variables, they take on an ordered set of numerical values within a certain range or continuum. Example would be age. You can actually have height of, example would be 170.5 centimeters. This will, in comparison or in contrast to discrete variables, wherein it can only assume the value of a whole number, in continuous variable, you can actually have decimal or fractions, or any of that infinite number that exists between two numbers. Example would be an age. This is, I'm sorry, this is not the appropriate example. Oh my god. Okay. You have age, that is 5.5 years. Height pala yung example kanina. height, that is 170.5 centimeters. So the continuous variable could take a value in between 2 points. So basically 5.5 is between 5 and 6. 170.5 is between 170 and 171 centimeters. So within a number like example 1 and 2, there actually exists an infinite number of possible values that a continuous variable can assume. So again, we have the categorical variables, which assume categories or nominal values. We have discrete variables, which could only assume whole number values, and then continuous variables, which could assume whole numbers together with, or whole number with a decimal or fraction values. So variables could also be qualitative or quantitative variables. If you say qualitative, these are just mere descriptions of a particular variable. It does not have any numerical value or numerical bearing. Example would be rating something as attractive or not attractive. So that is just a quality that you are describing. It does not actually have a numerical value. Helpful or not helpful, and consistent or not consistent. Now for quantitative variables, example would be reporting the number of times that something has happened, which basically talks about frequency, or the number of times that someone engaged in a particular behavior. So quantitative variables are those that assume numerical values, whereas qualitative variables are those that assume nominal values or descriptions. Okay, so defining variables. The definition of variable as it is conceived. So this is conceptual definition. So again, this was already been discussed in the previous slides, wherein we differentiated between what a conceptual definition is as well as an operational definition. So conceptual definition. So definition of variables as it is conceived. So how it is being defined by references such as dictionaries or search engines. And then we have here defines the characteristic to measure. This is the operational definition. Okay, it should be objective, observable, and is sufficiently clear and explicit to avoid ambiguity. This is to ensure that similar findings could be obtained if the study were performed by different researchers. So for the operational definition, you need to provide the method by which you measure the variable, how you categorized it, if applicable, and how you would also be able to test it. Because just in case if future researchers also want to conduct a similar study as your own, or if anyone wishes to confirm the results of your study and they want to replicate your study to determine if your study is actually credible and it is true, then they would be able to actually derive the same set of values as long as they follow the way they have measured the variables. So here, operational definition, again, it is the definition of a variable as how it is being measured in the study, which should be objective, observable, and sufficiently clear and explicit to avoid ambiguity. Okay, so for example, we have here obesity. So obesity is actually defined as the excessive fatness or overweight, etc. So that is the conceptual definition of obesity. And an example of the operational definition of obesity is weight based on weighing with a bathroom scale. So you have already identified the method by which it was measured. In underclothes without shoes, how the subject must be prepared for the measurement. So the subject must only wear underclothes without shoes and then weigh himself on a bathroom scale. which exceeds the upper limit of BMI of the subject's sex, age, and height. So that is how obesity is being used in that particular study. Okay, moving on to the scales of measurement, we have categorical values. So this consists of two or more mutually exclusive categories that are often presented as counts. These are nominal variables. Variables are divided into a number of named categories. That is again nominal variables, two or more exclusive categories. Again, for example, would be race, which could either be Filipino or American, Korean. Or another example would be hair color, as earlier. Second, the responses are divided into a number of categories that can be ordered as one above another, still under categorical values, but one assumes a greater value than the other. This is ordinal variable. Ordinal variable, or the way to remember it is ordinal order. We can place the categories in order since one of the values of that category actually assumes a higher value than the other. So for example, we have knowledge. We could actually categorize it into low, fair, or good level of knowledge. This is just an example. Or we also have opinion. You can have strongly agree, neutral, or disagree. Okay? So nominal variables, ordinal nominal values, these assume values that are neither greater nor less than the other. They are often presented as frequencies under each of the categories. And then we have the ordinal variable, which can be ranked with values that can be assumed to be greater or less than the values of the other categories. Next scale of measurement is numerical. So this consists of a continuum of measurements, a type in which there is an unlimited number of equally spaced categories. It also consists of actual measurements of individuals. Numerical scales of measurements are basically numbers. Okay, so for example, you have here age. Age could be 1 year old or 30 years old. Then another example would be hemoglobin level. You have 8.5 milligrams per deciliter. You can have 13 milligrams per deciliter or 15.5 milligrams per deciliter. So like that. Anything whose values are numerical form. Okay, so example of a framework for defining variables. So here is an example of a variable definition. You can look for the other example which are found in your notes. So example here, I have chosen hemoglobin. So the definition of hemoglobin is hemoglobin concentration in capillary blood measured by hemoglobinometer. So this is a operational definition of hemoglobin. This is measured by a hemoglobinometer. But if you say conceptual definition of hemoglobin, that would then be the protein found within your red cells responsible for carrying oxygen to the different parts of your body. But if you say how it is being measured or its operational definition, then this would be it. Hemoglobin concentration, it is specified in capillary blood. So if you were to test for hemoglobin in this type of research, then you would only use capillary blood and you use a hemoglobinometer to determine its level. And then scale of measurement is numerical, particularly the label would be grams per deciliter. Okay, so that is for the variable. Again, to recall, we have the confounding variable, the independent and the dependent variable. We have the categorical variables, which assume classifications by name. And then we have the discrete variable, which only has specific whole number values. Continuous variable, which could assume values of a fraction or decimal. And then we have discussed about the differences between qualitative variables and also quantitative variables. Then we have defined or differentiated conceptual definition and operational definition of variables. Then to the scale of measurement, starting with the categorical, we have differentiated the nominal variables and the ordinal. Again, for nominal variables, they have categories which are neither greater than the other, neither greater nor less than the other. And for ordinal variables, these are actually categorical values that could be assumed as one being greater or less than the other. And then numerical variable, which consists of a continuum of measurements. Okay, now would be the hypothesis. Okay, so your hypothesis is actually educated guess educated guess and a testable guess about the answer to your research question. So it is an attempt by the researcher to explain the phenomenon of interest. So for the functions of your hypothesis, this first provides a tentative explanation of the phenomena and facilitates the extension of knowledge in the area. Second, it provides with a relational statement that is directly testable in a research study. So your hypothesis is basically a prediction of the relationship between one variable or the other. For example, in our hypothesis state or goes, there is no significant relationship, or there is a significant difference or a relationship between the variables that you are examining. And another function of hypothesis, it provides direction to the research and a framework for reporting the conclusions of the study. Because again, in conclusions, you would actually be stating the results of the hypothesis testing, and then you would elaborate from there. So that would basically, hypothesis would provide framework for reporting conclusions of the study. Again, hypothesis is an educated guess. It is something that you initially assume at the start of your study, whether one variable is correlated with the other, or there are differences in the means of two groups. And it also provides direction or framework for reporting conclusions of the study. Okay, for the types of hypothesis, we start with the null hypothesis. So a null hypothesis is basically a negative statement negative statement which indicates the absence of a relationship or correlation between two variables. It predicts that there will be no differences between the variables being studied, or that there will be no relationship between the variables being studied. So a negative statement in a sense that it does not assume that a relationship exists between two variables. Next would be the alternative or alternate hypothesis, which is just the opposite of a null hypothesis. So a null hypothesis is a negative statement of your assumptions, whereas an alternate hypothesis is a positive statement. Positive form of the null hypothesis. So an alternate hypothesis actually predicts that there will be a difference between the variables being studied, or a relationship between the variables being studied. So it assumes that there is either a difference or a relationship between the variables being studied. So an example here, a research study investigating the effects of a newly developed medication on blood. So this is actually a research problem, or basically the relationship that you wish to examine. Either if there is a relationship in the newly developed medication on blood, this is actually blood pressure. Sorry, this is actually blood pressure. Okay, so your null hypothesis would be there is no significant difference in the blood pressure levels between two groups, and the alternative hypothesis would be there is a significant difference in blood pressure levels between two groups. So here it is, there is no, which is a negative statement, and the alternative is there is a significant difference. So between the two, it is actually the null hypothesis that is being tested in a research study, because the null hypothesis, it states, or it assumes that there is no relationship or difference that exists between the variables. So the reason why it is being tested, because until then that you can provide that there is indeed a relationship, you must first assume that the relationship does not exist. So that's why by the end of the statistical test, it is the null hypothesis that is either rejected or accepted, because in the first place, it must be the one that is used, because it does not assume any relationship yet until the null hypothesis is proven to be false, which then leads us to accept the alternative hypothesis, which claims that there is indeed either a relationship or significance between the variables in the study. Okay, we have here directional hypothesis. This is under alternative hypothesis. It states that there will be a difference, and aside from stating that there will be a difference, it also specifies how two variables will differ. So, diba, as discussed in alternate hypothesis, this actually claims that there exists a relationship or difference, and in directional hypothesis, aside from claiming that, it also specifies as how those two variables will actually differ. So here, positive or direct relationship. When the value of one variable increases with the increase in the value of another. Second, the relationship is negative when the value of one variable increases as the value of another decreases. On the other hand, we have also here non-directional hypothesis. So it still predicts that there will be a difference, so it is still an alternate hypothesis, but it does not specify how the variables will differ. So different from the directional hypothesis, wherein it does not just state that there will be a difference, but also specifies as to how they will differ. Okay, so example would be effects of a memory enhancement class on college students' memories. The directional hypothesis, which states that there is a difference and also specifies how those two variables will vary, would go experimental group will perform better than the control group in the memory test. So there is a specification as to how those two variables will actually differ. So experimental group will perform better than the control group. And in a non-directional hypothesis, it will only state that there is a significant difference between the performance of the two groups. It does not provide which of those two groups would actually be higher or lower. So again, these are the directional hypothesis as well as the non-directional hypothesis. Okay, we have now finished